Hey everyone, welcome back to the channel. If you're working on heavy equipment, you've probably seen your share of confusing fault codes. Today, we're re-diving deep into one that can be a real headache. SPN 641 FMI 9. This one pops up on all sorts of machines from excavators to loaders, and it can really stump you if you do want to know what you're really looking for. So, what exactly is this code telling us? In simple terms, SPN 641 FMI 9 means there's an abnormal update rate in your CAN communication network. Think of the CAN bus as the nervous system of your machine. It's a network of wires that allows all the different electronic control modules, or ECUs, to talk to each other. The engine controller needs to talk to the transmission controller, which needs to talk to the hydraulic controller, and so on. They're constantly sending messages back and forth. FMI 9, abnormal update rate, tells you that a specific module, identified by SPN 641, which is the variable geometry turbocharger actuator, isn't sending its messages at the expected speed. It's like having a conversation where one person suddenly goes silent or starts talking too slowly. The other modules are waiting for information, and when they don't get it on time, they flag this fault code. So, why does this happen? The root causes can be surprisingly varied. It's not always a bad turbo actuator. One of the most common culprits is actually a wiring issue. The CAN bus network is usually made up of two twisted wires, often called CAN high and CAN low. These wires can get damaged from vibrations, rubbing against a frame, or exposure to heat and chemicals. A short circuit, an open circuit, or even just corrosion in a connector can disrupt the signal and cause this code to appear. So, the very first thing you should always do is a thorough visual inspection of the wiring harness between the main engine ECU and the turbo actuator. Look for any signs of wear, chafing, or damaged pins in the connectors. Sometimes, just wiggling the harness while the engine is running can make the problem come and go, which is a dead giveaway you've got a wiring problem. Another major cause can be power and ground issues. The turbo actuator needs a stable supply of voltage and a solid ground connection to operate correctly. If the power supply is intermittent or the ground is weak, the module can't function properly and will drop off the network, triggering the FMI 9 code. Use a multimeter to check for proper voltage and ground at the actuator's connector. Don't just check for voltage. You need to load test the circuit to make sure it can carry the necessary current under load. A simple test light can sometimes reveal a weak connection that a multimeter might miss. Also, don't forget to check the machine's batteries and main power relays. A system-wide voltage drop can cause all sorts of strange communication errors. Now, let's talk about the network itself. Sometimes, the problem isn't with the wiring to the turbo actuator, but with the CAN bus backbone. Other modules on the same network could be causing interference. A failing ECU somewhere else on the machine could be screaming on the network, flooding it with bad data and preventing the turbo actuator from communicating. To diagnose this, you might need to check the resistance of the CAN bus. Type E. A healthy CAN bus will have a resistance of around 60 ohms when the key is off and the batteries are disconnected. This is because there are two 120 ohm terminating resistors at each end of the network, and in parallel, they equal 60 ohms. If you're getting a reading of 120 ohms, it means one of the terminating resistors is missing or the circuit is open. If you're getting a reading close to zero, you've likely got a short between the CAN high and CAN low wires. Finally, after you've exhausted all the wiring, power, and network possibilities, it might actually be the turbo actuator itself that has failed. The internal electronics can go bad, causing it to stop communicating. Or the mechanical side of the actuator or the VGT mechanism in the turbo could be sticking, causing the electronic part to fault. If you have access to a known good actuator, swapping it in can be a quick way to confirm if the part is the problem. But given their cost, this should be your last step after confirming everything else is perfect. To recap, when you see SPN 641 FMI 9, don't just jump to replacing the turbo actuator. Start with the basics. Check the wiring harness for damage. Verify you have good power and ground. Test the integrity of the CAN network itself. Only after you've ruled out these common issues should you consider replacing the component. Following a logical diagnostic process will save you time, money, and a lot of frustration. I hope this breakdown helps you the next time you encounter this tricky code. If you found this video useful, Give it a thumbs up and hit that subscribe button for more heavy equipment diagnostic tips. Let me know in the comments if you've ever fought with this code and what the solution was. Thanks for watching, and I'll see you in the next one.